Solana's recent price rally has been largely driven by the announcement from VanEck, the first U.S. firm to file for a Solana ETF with the SEC. This move has ignited optimism among traders and analysts alike. In addition, Bloomberg analyst James Seifart's prediction that the Solana ETF might be approved by 2025, leading to a significant influx of investor interest and price gains. Notably, the excitement around Solana's ETF prospects underscores how powerful market sentiment and speculation can be in driving price action. On the other hand, Avalanche, Avax, has been capturing investor interest for reasons that extend beyond immediate ETF speculation. Recently, market expert Quinton identified Avax among a list of cryptocurrencies likely to receive ETF approval by 2025. Alongside Solana and Chainlink, Avax was highlighted for its strong potential, fueling positive sentiment among investors who anticipate long-term gains from possible ETF endorsements. However, Santiment, a prominent on-chain analytics firm, provides a contrasting perspective on the two cryptocurrencies' rallies. Solana is a blockchain with striking resemblances to Ethereum. In fact, it's frequently referred to as an Ethereum killer. Like Ethereum, the SOL token can be bought on most major exchanges. The token's actual value is in conducting transactions on the Solana network, which has rare advantages. The Solana blockchain uses a proof-of-history consensus mechanism. This algorithm uses timestamps to define the next block in Solana's chain. Most early cryptocurrencies, such as Bitcoin and Litecoin, use a proof-of-work algorithm to define the blocks in their chains. Proof-of-work uses a consensus mechanism that relies upon miners to determine what the next block will be. However, this proof-of-work system is slow and resource-heavy, leading to the use of tremendous amounts of energy. This is one reason why Ethereum converted to a proof-of-stake system, reducing energy consumption by 99.9%. Unlike the earlier proof-of-work mechanism, proof-of-stake uses staking to define the next block. Staked tokens are held as collateral by the blockchain until validators reach a consensus about the chain's next block. According to Konstantin Anisimov, chief operating officer at crypto exchange CEX.io, Solana uses a mixture of time-tested cryptographic strategies and fresh innovations to address the shortcomings of crypto's first-wave solutions. Powered by its unique combination of proof-of-history and what's referred to as delegated proof-of-stake algorithms, the main problem Solana was attempting to solve was Ethereum's scalability issues. Delegated proof-of-stake is a variation of the more traditional proof-of-stake algorithm. For those who need a refresher, the proof-of-stake mechanism is a process of transactions for creating new blocks in a blockchain using a system of validators. Solana brings users several advantages with its delegated proof-of-stake mechanism. The history algorithm adds a layer of security to the network, says Christian Hazim, analyst at ETF provider GlobalX. In essence, Solana addresses 2 out of 3 issues identified by Ethereum co-founder Vitalik Buterin in his blockchain trilemma of scalability, security, and decentralization. Even though Buterin initially claimed Ethereum would address all 3 aspects of this trilemma, most experts believe that it only addresses 2 factors, decentralization and security. However, Solana is designed to address 2 parts of the trilemma, scalability and security. SOL's proof-of-history algorithm presents unique security for the network. While the speed with which the Solana platform performs computations allows for increased scalability. By using a unique blend of proof-of-history and delegated proof-of-stake, Solana offers exponentially faster transaction speeds than its closest competitors, Ethereum and Cardano, ADA, at a fraction of the cost, Anisimov says, by using a unique blend of proof-of-history and delegated proof-of-stake. Unlike proof-of-work, which utilizes the miners themselves to define the next block in a chain, or proof-of-stake, which uses staked tokens to define the next block, proof-of-history uses timestamps in its definition of blocks for the Solana chain. This innovative system lets validators on the blockchain vote on the timestamps of different blocks in the chain. This continues to keep the chain relatively decentralized while simultaneously allowing for more secure and faster computations. Solana works on a combination of proof-of-history and delegated proof-of-stake protocols. The reason for this combination of protocols, Brian Routledge, associate professor of finance at Tepper School of Business at Carnegie Mellon University, says Solana is trying to process lots of transactions quickly. Routledge points out that trying to process transactions quickly usually requires centralization. For example, Visa uses a huge network of computers to keep its processing speed on track. Bitcoin, on the other hand, Routledge says, processes transactions very slowly to remain decentralized. Since the entire point of blockchain technology is to provide decentralized systems, Solana attempts to process transactions at speeds akin to a large, centralized company like Visa while maintaining the decentralization of Bitcoin. This speed allows for increased scalability since the environmental and monetary costs of Solana's systems are lower. The speed at which blocks are added to Solana's blockchain requires additional levels of security for the blockchain. This is where Solana's proof of history algorithm comes into play. This algorithm timestamps each block in such a way that maintains the system's security. Solana's SOL tokens are then staked and used as collateral to process transactions on the network. These transactions include everything from validating smart contracts to using Solana as a non-fungible token (NFT) marketplace. In August 2021 came one of Solana's big breaks, and more than a year later Solana launched when Degenerate Ape Academy became the first crucial NFT project on the Solana NFT marketplace. During the first 3 weeks of that month, Solana's price jumped from around 2,496 Indian rupees to 6,241 Indian rupees in value. Solana's all-time high was in November 2021, when it peaked at nearly $260 during the height of the crypto bull run. Like most of the world's major cryptocurrencies, SOL tokens can be traded on any number of platforms. This includes centralized exchanges like Binance.us, Coinbase, and Kraken, to name a few. In some cities around the globe, SOL tokens are even available in crypto and NFT ATMs. After purchasing SOL tokens, investors will want to store the tokens in a crypto wallet. Unlike the name suggests, crypto wallets are not where cryptocurrencies themselves are stored. Rather, they are wallets where owners store the keys to their cryptocurrencies. These wallets can either be stored offline or online. The safest option for storage is offline with a cold wallet. SOL tokens also have many use cases. Among other things, they can be used for peer-to-peer payments, trading, and as an incentive to secure the Solana network as a validator. But as with all cryptocurrencies, investors should consider speaking with a financial advisor before investing in Solana. Cryptocurrencies are highly volatile and extremely risky investment vehicles. Investors should be certain they can afford to lose the money they invest in SOL, even if they believe in Solana's potential. Solana's focus on user experience, UX, is a significant aspect of its appeal, particularly in how it addresses some of the common pain points experienced in blockchain and cryptocurrency adoption. Another unique aspect of Solana is its approach to scalability, achieving high throughput without relying on Layer 2 solutions. In typical decentralized blockchains, the process of handling an increasing number of transactions often leads to slower performance due to timing differences between nodes in the network. Solana, however, tackles this issue differently. Its POS mechanism selects a single leader node responsible for organizing and sequencing the transactions between various nodes. This approach streamlines the process, reducing the overall burden on the network and enabling faster transactions. Despite its advantages, Solana is not without its share of challenges. It is still vulnerable to tend toward centralization due to the relatively high computing resources required to become a Solana validator.